Hello friends, welcome again to this new video. In this video, we will study one more important aspect from the chapter Chemical Kinetics. That is what? The order of reaction. Now try to understand what is this concept, order of reaction. Let us see the definition. The sum of powers or exponents of concentrations of the reactants in the rate law expression is called order of that chemical reaction. That is what? The sum of powers or the sum of exponents of concentration of the reactants in the rate law expression is called the order of that chemical reaction. Let us see the explanation. Consider a general reaction. AA plus BB gives CC plus DD. If the rate of reaction is given as like this, rate is equal to K molar concentration of A raised to power X into molar concentration of B raised to power Y. Then the sum X plus Y, that is the sum of the exponents or the sum of the power of A and B or the concentration terms A and B gives overall order of the reaction. The sum of powers or the exponents of the concentration term, that is X plus Y, gives overall order of the reaction. Thus, overall order of the chemical reaction is given as sum of powers of the concentration terms in the rate law expression. So this is very simple aspect. So that is what when the rate law expression is given there or rate law equation is there, the sum of the powers, just simply the sum of the powers or the exponents of the concentration terms in the rate law expression gives the order of reaction. पहा, फार सिंपल किंवा साधी अशी ही कॉन्सेप्ट आहे. आपण पाहिलं रेट जो आहे एखाद्या केमिकल रिॲक्शनचा, जो की अशा पद्धतीनं रेट एक्सप्रेशन किंवा रेट इक्वेशन किंवा आपण ज्याला रेट लॉ म्हणतो त्यांनी दिलेला असतो. आणि याच्यामध्ये ऑर्डर ऑफ रिॲक्शन काय आहे? दॅट इज जस्ट द सम ऑफ द पॉवर्स और द एक्सपोनेंट्स ऑफ द कॉन्सन्ट्रेशन टर्म्स which are used in the rate law expression. So therefore order of reaction is just X plus Y, whereas order of reaction with respect to A, see here X, the order of reaction with respect to the first reactant A is X and order of reaction with respect to B is Y, and the overall order of this general reaction is nothing but X plus Y. Now see the key points about the order of reaction. The characteristics or the important points, key points about the order of reaction. The order of chemical reaction is experimentally determined. So again, this is very important. What is that? As that of the rate law expression or as that of the rate law, the order of a chemical reaction is also experimentally determined. So that is all. It is not possible to predict the order with the help of the stoichiometric balanced equations of the chemical reaction. So see, what are the key points of the order of reaction? So order of reaction, it is experimentally determined thing. the order of reaction is not related to the stoichiometric equation of the reaction, or it does not depends upon the coefficients of the reaction. So it is experimentally determined thing. Furthermore, the order of reaction cannot be predicted from balanced equations of the reaction. It is important to note that reaction order is always defined in terms of concentrations of the reactants and not of the products. So, what is the another important point? The order of reaction is determined only from the concentrations of the reactants and not that of the products. And the order of reaction can be 0, 1, 2, 3, any integer, and even a fraction. A zero order reaction means that the rate of reaction is independent of the concentration of the reactants. So, depending upon the order, so it may be 0, it may be fraction, or in the integer of 1, 2, 3 like this. So, depending upon this, the various types of order are there. If the order is 0, it means that the rate of chemical reaction is independent of the concentration of the reactants. Now see the types of order of reaction. So again, this is very simple aspect. Once we understood the order of reaction, then it is easy thing to see whether it is 0 order, first order, second order, like that. So these are the types of order. First order reaction. Now see what is mean by first order reaction. Look at this. For the reaction, let us consider this general reaction or one more specific reaction, that is decomposition of hydrogen peroxide. It gives liquid water plus oxygen. Experimentally determined rate law is like this. So we have already studied the rate law. So that can be how the rate of a particular chemical reaction is related to the exponents or the powers of the concentration terms that is given by the rate law. And therefore, the order of reaction is also the experimental thing. And in this case, the experimentally determined rate law for this reaction is this. That is, rate is depends upon the molar concentration of this reactant, that is H2O2. So rate is given like this. So it indicates what? The rate is depends upon, in this case or in this reaction, only on the concentration of the hydrogen peroxide H2O2, and that's why this is called as the first order reaction, and that can be represented like this. See here. So this is the example of first order reaction. So mind well again. So this is the experimentally determined thing. So by performing the number of experiments, the rate law expression is put forth, and again in this case from that expression one should know the order of reaction. So what is the order of reaction? That is, the rate of this reaction is depends on the concentration of this reactant. And how it depends? Like this. That is the linearly proportional. Again, rate is linearly proportional to this, as the concentration terms power raised to 1 means again rate is linearly proportional. What it means? The concentration of H2O2 increases, the rate of chemical reaction also increases. Then second order reaction. If the experimentally determined rate law for the reaction is like this. See, another example. H2 plus I2 gives 2HI. So experimentally determined rate law equation or rate law expression or rate law for this reaction is what? This is rate is equal to, where K is the proportionality constant. See here, the molar concentration of H2 raised to power 1 into molar concentration of I2 raised to power 1 It means that again the rate is depends upon the concentration of the both reactants and again linearly proportional to the concentrations of these reactants, and that's why again now see here the order of reactant, this first reactant is 1, the order of the second reactant again is 1, but the overall order of reaction, the reaction is of first order in H2 and also first order in I2 each, and hence overall of second order. That is the sum of the exponents or the powers that gives the overall order of the reaction, and that's why this is an example of second order reaction. Understand? Now see, what is the third order reaction? Only a few reactions of third order are known. Reactions with orders higher than 3 are scanty. Paha. Third order reactions. So very few reactions are observed in which the order of reaction is third or 3. Look at this example. 2NO gaseous plus 2H2 gaseous gives N2 gaseous plus 2H2 gaseous. So rate, experimental determined rate equation or rate expression or rate law is like this. Now see here, rate is equal to what? The molar concentration of NO raised to power 2 into molar concentration of H2 raised to power 1. So how the rate is depends on? So on this concentration, how rate is depends, and on this concentration term, how rate is depends. So that is like this. So that's why the overall order is the sum of the powers of the concentration terms, so that is equal to 3, and that's why the order of reaction is here 3. Then zero order reaction. So I have told that zero order means rate of the reaction is independent of concentration of reactants. What is the meaning of zero order? So if the rate of reaction does not depends upon the concentration of the reactants, such reactions are called as zero order reactions. Here, decomposition of ammonia into nitrogen and hydrogen gas. So the rate expression which is experimentally given, see here. So this is example of zero order reaction. The rate does not depends upon the concentration of the ammonia, and that's why this is example of zero order reaction. Let us consider one more example, H2 plus Cl2, that is formation of 2HCl gaseous. Again this is an example of zero order reaction. The rate of reaction does not depends on the concentration of the H2 first reactant or concentration of the Cl2 second reactant, and the overall reaction is the zero order reaction. Sometimes order of reaction may be the fraction. In fraction, let us consider the example. Order of reaction can be fractional like this. So acetaldehyde, when decomposed, it gives methane gas plus carbon monoxide gas. The rate law for the reaction was found to be, that is rate is equal to, now see here, look at this, that is molar concentration of acetaldehyde raised to power 3 by 2. So that is what? That is the fraction. How the rate of this reaction depends on what type of concentration? That is the concentration of acetaldehyde in the power, that is 3 by 2. So in this way there are the various types of order of reaction. So we have the numericals based on the order of reaction. So simple numericals are there again. So first of all, see again two examples regarding to this. NO2 gaseous plus CO gaseous gives NO gaseous plus CO2 gaseous. In this reaction, the rate expression for this is like this. So again, from stoichiometrically balanced chemical equations, we cannot determine the order of reaction. So that is the experimentally determined thing, and that is given here like this. Rate expression or rate law is like this. So from this we understand what? That is with respect to the concentration of NO2. See here how the order of reaction is there. So with respect to this NO2, the order of reaction is 2, and with respect to CO the order of reaction is 0, means again independence, and therefore this shows that the order of reaction with respect to NO2 is 2 and with CO is 0, or rate is independent of concentration of CO. Overall reaction is a second order reaction. Let us see one more example, that is the chlorination of methyl trichloride, formation of carbon tetrachloride plus HCl. So experimentally it is observed that the rate is depends upon how, like this here, the molar concentration of methyl chloride, methyl trichloride, and the molar concentration of HCl. Again, the overall order reaction is sum of these. So that is 1.5, or we can write overall order reaction is 3 by 2. So that is in fraction. So these are the examples. We will try to solve the numericals. So simple numericals are there. I will try to explain. So there may be the question, find out the overall order of reaction or calculate the rate constant, like that. See here, look at this. The rate of the reaction, a general reaction is given there. A plus B gives P, and the rate is given 3.6 into 10 to the power minus 2 moles per decimeter cube per second. When molar concentration of A is like this and molar concentration of B is like this, calculate the rate constant if the reaction is first order in A and second order in B. So what we have to calculate in this reaction? We have to calculate the rate constant, that is the K. And what is given? Look how to solve this. So what is given? That is the rate of this reaction is given. Furthermore, the molar concentration of A is given. Molar concentration of B is given. See here, how to determine the rate. Solution. The reaction is first order in A. With respect to A, reaction is first order and second order in B. Hence the rate law is used. So we can write from this given rate law. We can write like this. See here, rate is equal to what? So once we study the order of reaction, then one should be able to write the rate law expression from the provided information. So see here, so from this we can write rate law. We have to write here rate expression or rate law. Rate law is equal to what? That is K, proportionality constant, molar concentration of A. So in this case, that is, it has the first order, and that's why not written here. Molar concentration of A into molar concentration of B, second order. With respect to this concentration, order is second, and that's why written here 2. So once we are able to write the rate equation, rate expression from the given information, it is easy thing to determine the then rate constant or rate or the order of reactions here. Or now this can be rearranged. K is equal to what? Rate divided by this, like this. Now substitute the values. The rate is given, value of A is given, value of B is given. So just put the values. Look at this. The value of rate is kept here. Then molar concentration of A and molar concentration of B, its square is there. Its square is there, like this. And then this calculations are very simple again. 0.2 into 0.1. Is it right? Then similar terms get cancelled here. So finally we will get what here? After making these calculations, simple calculations are there, we will get 18 moles, 18 per moles square. Look at this, decimeters per 6 power 6 per second, like this. So unit that can be obtained by cancelling here. So moles per decimeters cube get cancelled here. Its square, mole square, decimeters 6 power 6, like that. So we will get such type of unit here. So finally that is the rate constant. So don't bother about the unit being a constant. We know that there is no need to write the unit. So we will get here like this. 18 is the answer. So what is that? The rate constant of this. Then See, one more numerical. The rate of the reaction is given like this here. Such type of reaction is their general reaction. 2A plus B gives 2C plus D. The rate again is given here. When A is equal to B, molar concentration of A is equal to B, and that is given 0.3 moles per decimeters cube. If the reaction is of first order in A and 0th order in B, what is the rate constant? So similar numerical is there. We have to determine again rate constant. The molar concentration of A and B are equal and given, and order of reaction with respect to A is first order and with respect to B is 0, and the rate is given. As the reaction is of first order in A and 0 order in B, rate is given like this. Look at this. Rate is equal to what? K molar concentration of A raised to power 1, because the B with respect to B, see here, the order is 0, and that's why we can write like this, simple. So once we can write this, then this is very simple thing to solve this numerical. Then rate, the value of rate, then molar concentration of A is given. So we have the formula, then K is equal to, we have to calculate the constant, rate constant. That's why rate constant is equal to rate upon molar concentration of A. So as its power raised to 1, so need not to write here again. So put the values. So simple. Again, by making the cancellations or dividing this, we will get, see here, 2 into 10 to the power minus 3 per second. So that is again rate constant value we will get like this. That is what rate constant for this. So in this way, we can easily determine the rate constant with the help of this given data. Then one more somewhat different numericals here. Consider a general reaction. A plus B gives B. If the concentration of A is doubled, see here. So we have to use somewhat logic here. Again, slightly different numerical. If the concentration of A is doubled with B being constant, the rate of the reaction doubles. If the concentration of A is tripled and that of B is doubled, the rate increases by factor 6. What is the order of reaction with respect to each reactant? Determine the overall order of reaction. So in this numerical, now we have to calculate or determine the order of reaction from the provided information. See here, simple numerical is there. The rate law of the reaction can be written. So we don't know what is the order. We don't know what is the order. So then we can write the general rate law, or what we call it, differential rate law. Differential rate law or rate law or rate expression. So we can write this general simply. Rate is equal to K molar concentration of A raised to power X, molar concentration of B raised to power Y, where X and Y. So that is the order of reaction, that one is assumed. What we have to determine the values of this X and Y. So what is our attention? We have to determine now the values of this X and Y. Then we will get the order of reaction. So how to determine? This is simple. See, look at this. What is given in numerical? If A is doubled, the rate doubles. See here. When A is doubled, the rate doubles. Look at this, hence 2 into rate. When 2 into rate? When A is doubled. See here. पहा कशा पद्धतीने सॉल्व केलाय न्यूमेरिकल त्यांनी. दिलेली माहिती काय आहे आपल्याला. मोलार कॉन्सन्ट्रेशन ए जर डबल केलं तर रेट डबल होतो म्हणतोय. तर म्हणून इथे पहा 2 into रेट, आणि हे मोलार कॉन्सन्ट्रेशन ऑफ एचं आपण काय केलंय, डबल केलंय. एक्सपोनंट्स आपण अप्रॉक्सिमेटली एक्स आणि वाय घेतलेले आहेत इथे. आता पहा, सो दॅट कॅन बी रिटन लाईक दिस. हे अशा पद्धतीने लिहिता येतं. थोडंसं लक्ष द्या याच्याकडे. पहा, याला स्प्लिट करता येतं. 2 raised to x molar concentration of A raised to x and a cell. So this can be written in the form of like this by splitting. Okay. So let us consider this is the expression second. Now divide expression second by first. या second ला आपण first ने divide केलं. कंपेअर करत आहोत आपण दोन्ही रेट. अगोदर रेट असा होता, या कंडिशन्सला रेट असा झाला, म्हणून डिवाइड करत आहोत आपण. डिवाइड सेकंड बाय फर्स्ट. सी आर सेकंड ही एक्सप्रेशन जशाल तशी इथे घेतलेली आहे. तिला फर्स्टने डिव्हाइड केलेला आहे, लक्षात येईल तुमच्या. सो या ठिकाणी 2 राहील हे, आणि या ठिकाणी हा एक्स फॅक्टर राहील, बाकीचं कॅन्सल होईल. पहा, लाईक दिस, अशा पद्धती. सॉरी, इथे 2x राहील, सॉरी, इथे 2x राहील. आहे, बाकी ए एक्स एक्स बी बी वाय वाय हे सेम जे आहेत ते कॅन्सल होईल, ते रेट कॅन्सल होईल. 2 इज इक्वल टू 2 power x, that is what. And now, so we will get what? Hence x is equal to 1. X is equal to 1. So in this way, we can determine the value of x. So this is the order of reaction with respect to the A. Order of reaction with respect to the first concentration term A. Then if molar concentration of A is tripled, what is the another condition in the numerical? A is tripled, then B is get doubled, and rate is get increased by factor 6 times. So this can be written. Look at this. 6 into rate. When rate is increases by 6 factor, when the concentration of A is tripled, see here how it is written, tripled, and the concentration of B is get doubled, like this. At that time the rate is increases by 6 times. Again, we have to compare this third equation with first one. This situation, this condition, we have to compare with first, and then dividing third by first. Look at this. Just this third is divided by again the first, and we will get like this. See here. So what remains? 6, and here 3. That is what. And see here, 1y is remaining here. 2y. This 2y. Look at this 2y. Yes, rate get cancelled. K get cancelled. AX get cancelled. BY get cancelled. What is remaining? 6. Then 3 and 2y. That is written here. 6 is equal to 3 into 2y. Then, so we can how to solve this? 3 इकडे घेऊ शकतो आपण. काय राहील मग? 3 या 6 ला डिवाइड केला आपण. 2 is equal to 2y. 2 is equal to 2y, and finally y is equal to what? Then again y is equal to 1. So thus the reaction is first order in A and first order in B. The overall reaction is of second order. So that is what, how to determine the order of reaction from the given data. So again, this is the very simple aspect, that is the order of reaction. So in the chemical kinetics, so this is one more important term, order of reaction. So what we have studied here, definition of order of reaction, that is what is meant by order of reaction. Then the key points or characteristics of the order of reaction. Then types of order of reaction, and the numericals based on the order of reaction, in which how to calculate the rate constant and how to find out or determine the order of reaction from the provided information. So this is enough for this. So thanks. Don't forget to like and subscribe in order to watch the incoming videos based on this. So we'll stop here. Thank you.